In Activity 5, Is It Inclined to Erode?, students use their stream tables to examine the relationship between slope and erosion. They run water down the stream table at 3 different slopes and then observe erosion and deposition characteristics that result from the different slopes of terrain. You'll need the following materials from the kit: Activity Sheet 5, plastic containers with holes, 1-liter containers, stream tables from Activity 2, and vinyl tubing. You will also need to provide items to elevate the stream table, metric rulers, and tap water. To prepare for the activity, make a copy of Activity Sheet 5 for each student. Each team of 4 will need their stream table, a plastic container with hole, 2 1-liter containers, a metric ruler, items to elevate the stream table, a length of tubing, and some tap water. To begin the activity, have students recall the stream table experiments they conducted in Activity 2. Ask students, what caused the erosion in the stream tables? Students should remember that flowing water caused the erosion. Explain that still water has very little force to carry particles and therefore causes little erosion. Water that flows fast has greater force and therefore causes more erosion. Then ask students, how does the flowing water of a stream or river get this force? Most students will know that water will flow faster down a steep incline, and that the greater the speed, the more force the water has. Define slope as the angle of incline of a streambed or riverbed, and define variable as the condition to be tested in a controlled experiment. Inform students that in this activity, they will investigate the variable of slope and how it affects erosion. Next, have the teams retrieve their stream tables and distribute the materials. Instruct teams to insert one end of the tubing into the grommet in the stream table, and let the other end hang down into the 1-liter receptacle on the floor. Have students pour water from a 1-liter container until the sand is moist. Then smooth it out and reshape it so that it covers 2/3 of the grid and slopes gently toward the end with the hole. Then have them trace a shallow meander from the top of the stream table to the bottom, as they did in Activity 2. Next, instruct each team to elevate the sand-filled end of their stream table 4 centimeters, and then distribute a copy of Activity Sheet 5 to each student. Have each team position the plastic container over the sand, resting it between the pegboard and the edge of the stream table so that the hole in the bottom of the container is directly over the start of the meander. Then instruct them to fill the container with water, allow the water to drain into the stream table, and observe how many squares were covered up by eroded sand. Help the students to add fractions of covered squares together in order to come up with a total number of squares covered, and record their observations on their activity sheets. After the students have recorded their observations, tell them to smooth the sand to its original condition, draw a new meander, and refill the pouring container with the runoff in the receptacle. Instruct teams to increase the elevation of the stream table to 8 centimeters, and then conduct the experiment again. Next, have students increase the elevation of the stream table to 12 centimeters and repeat the test. Remind them to record their observations on the activity sheet. After everyone has finished recording their observations, ask students, how did increasing the slope of the stream table affect erosion? Students should relate that more squares on the grid were covered up by eroded sand with each increase in slope. Guide students to conclude that the steeper the slope of the stream bed, the faster the water flows and the more force the water has, increasing the effects of erosion. Have students fill in the last column on the activity sheet table, ranking the erosion at 3 elevations. Inform students that the speed of the water affects not only erosion, but also deposition. Deposition occurs when there is a decrease in the speed of fast-moving sediment-rich water. As the water slows down, there is less energy to keep the sediment moving, so the sediment settles to the bottom of the streambed or riverbed. The water in a stream or river can slow down as a result of several factors: a change in slope of the streambed, widening of the streambed, natural or artificial barriers in the streambed's path, or the streambed entering its base level. Finally, have students complete their activity sheets. To conclude the activity, instruct the students to drain the water from their stream tables but leave the sand, grid, and pegboard in place. Have them remove the tubing but leave the grommets and stack the tables for use in the next activity. Rinse and air dry the containers and tubing and return them to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.